This is the last installment of Tests of Significance in Chapter 10.2. Parts 4 and 5. We'll combine them together. We're going to check out the test for population mean, and figuring out what the significance test that we want to do isn't so easy. And our alternative hypothesis can rather be a challenge sometimes. But fortunately, doing the problem is rather easy. We're going to follow the 4 steps in the inference toolbox. Step 3 is the easiest with the calculator, and we'll get to that. Last I had you calculate it by hand using the z-scores and finding it on your A table. Step 4 is the most important. You must say what it all means. You must have context from the problem. And I said that when you are setting up your criteria in step 2, if you're very clear in that, it will help you in step 4. Here are the 4 steps from our textbook. These are the inference toolbox. You can follow those. Remember, in step 1, you're going to state the null and alternative hypothesis in words and symbol. You can also put this in step 2. But it has to be said clearly before step 3, before you calculate your test statistic. When your p-value, and that's that upper tail probability, is less than your alpha level, that established level, which we normally have said that it's at 5% or 1%. It changes from time to time, but that's what we use most often. If it's less than that, that means that it occurs so rarely that the null hypothesis must be wrong. And we call it statistically significant at level alpha, and we reject the null hypothesis. Okay? It doesn't mean that it's not true. We just have enough evidence where we think it's not true. Now, if the p, your probability, your p-value, upper tail probability, is greater than alpha, then it's not statistically significant at level alpha, and we say we failed to reject the null hypothesis. We never say we accept the null hypothesis. We just say we failed to reject it. At this point, we don't have enough evidence to say that it isn't true. We usually start off with the null and alternative hypothesis in step 1 or step 2. And H0 mu is equal to the population value. We're assuming that it is. Sometimes it's the difference between two values. Sometimes it's the value that is given to us in the problem. And then our alternative hypothesis, we're assuming that it's either going to be less, that our mu is going to be less than, greater than, or not equal to the value given in the problem. Then we standardize the sample, which is finding the z-score. Notice how we modify the standard deviation by dividing by the square root of n. Then we calculate the p-value, the upper tail probability that we should see an outcome this large or larger, or small or different, if it happens to be the lower tail probability, if it's less than, if the null hypothesis was true. And then finally, we interpret the answer. So we're given, in this particular example, that the z-score, the z-statistic, is 1.7. And it's a two-sided test. Well, that means it could either be negative 1.7, less than or equal to negative 1.7, or greater than or equal to positive 1.7. So in this particular case, and we can go either way, the book tells us to take and find that probability and subtract it from 1. So if we find the probability, that z-score of 1.7, subtract that value from 1, and since it's two-tailed, we have to double that. So it's 1 minus, in this particular case, 0.9554, and then we double it, and our probability is 0.0892. Well, if we look at that, that's greater than 5%, and it's greater than 1%, obviously. And so if this were our z-statistic, or our p-value in our problem, then we would say we failed to reject the null hypothesis in this case at the 5% and the 1% level. Here's our formula for finding the z-score. Okay. Now notice that they call this a z-test. A z-test is also the same thing as a hypothesis test and a significance test. So if you see this, don't freak out that you have 3 different things going on. They're all referred to as the same thing. Here are our examples and our normal distributions, and they're shaded in for each of the possible occurrences of our alternative hypotheses. We've gone over these, so these should be familiar to you. Please look at the example 10.13 and the z-test box on pages 573 and 574 for further explanations. Okay, let's talk about fail to reject here. If we find insignificant evidence to reject H0, like in the executive example that we had for the hotels, we do not reject H0. This does not mean that we have proven it to be true. We look for evidence that said it was different and didn't find enough, that's all. Be sure to always link your comments directly to your p-value. Never just say reject H0. Okay, based on our evidence, we fail to reject H naught, or we reject H naught. Look at example 10.14, page 575, and then do the exercises 10.38 through 10.40. Those were for today. For fixed significance test for a population mean. To test a hypothesis, we first compute the z-value of the statistic. We've already done that many times. And then we compare that to the critical value, the z-star, that we're looking at, say at 5%. You can look at your t-table in the back of the book, or the one that I give you, and if you see the z-star, the one that corresponds to 5% or 1%, if that z that you calculated from your problem is greater than your z-star, then you're going to reject H naught. If it's less than, you'll fail to reject H naught. Finally, decide to reject H naught or not reject H naught by comparing the two values. See the example 10.16 on 578, 579. Okay, and here are rules for rejecting or failing to reject H naught in each of the cases. Large z values. Large z values, those greater than 3. So suppose we calculate our z-score, and it's a really big number. You already know that it's off the chart on either tail. So if it's a -3, it's so small that it's hard to graph on your normal distribution. It may even be beyond what you have in your A table. So the alpha level only tells you when to reject it. It doesn't tell you how strong that particular p-value is. You can say, we reject it like crazy. That's fine. It's so far out there. Large z-values have such a low probability, it's far more accurate to just say how rare this occurrence will be rather than compare it to the alpha level. Okay, so if we're having an alpha level of 1%, but it's way, way below that, you don't want to say we reject it at the 1% level. Go ahead and say how low that p-value is. Tell everybody that it's strong. Tell everybody that it's a really, really small p-value and that occurrence is so rare that the null hypothesis must be wrong. Be confident in your answer. Test from confidence intervals. This is what we're supposed to do for part 5, and it's very quick and straightforward. If you calculate a confidence interval, and in this particular instance, we'll use the 99% confidence interval. Remember, at 99%, all that's left over is 1%, and you're going to divide that on each end of your normal distribution, so you have 0.5% on each end. Therefore, the level for a two-sided test is 1 minus z-star. A level alpha two-sided significance test rejects the null hypothesis exactly when the null hypothesis falls outside. So you calculate a confidence interval that corresponds to your alpha level, and if that value, that null hypothesis value, is not in that confidence interval, you just say you reject it. If it is in there, you say you're not going to have enough evidence to reject it. So basically all you're doing is calculating, once again, calculating a confidence interval that corresponds to your alpha level, and if your null hypothesis value is in that confidence interval, then you fail to reject H naught. If it's outside the confidence interval, you have enough evidence to reject H naught at that particular level. See the example 10.17 on page 581. I hope this is informative. Please review this and take notes, and if you have any questions, see me later.